and a warm welcome, my dear friends. Now we are going to start with a very interesting chapter called as polynomials. Polynomials is a very integral part of algebra, which is again a very integral part of the subject of mathematics. So polynomials will basically be about variables and numbers and equations and expressions. So before starting, let's try and understand what the dictionary definition of the word polynomial is. So now, as you can see, the dictionary definition of polynomials is an expression of more than two algebraic terms, especially the sum of several terms that contain different powers of the same variable or variables. So let's try and understand what this exactly means by taking an example. So basically, let's say if I try and write an expression like this. This is just a random expression. As you can see, here there are different terms in one variable x. So basically, x is the variable, right? And there are several terms which involve different powers of x. So try and understand. Here, this is 5x raised to 1. So the power of this particular x here is 1. The power of this particular x is 4, and here there is no x, so this is a constant term, and here it would be x raised to 0, which we no need to specifically write because x raised to 0 is nothing but 1. So as the definition goes, a polynomial is nothing but a term, several terms clubbed together where a particular variable or variables. Why I'm stressing on the thing variables? Because a particular expression can have more than one variables, which we will learn gradually. So these variables will have different powers and together will be called as a polynomial. So basically, to culminate, polynomial is nothing but a set of few terms in one variable or more than one variable with different powers, as you can see. So before going any further, let's start from the very basic thing. Let's understand what a constant is. So a constant is nothing but just a number. If I write 1, I can say yes, this is a constant. Likewise, if I write -7 for that matter, this is again a constant. Half is also a constant. So this is what a constant is. A constant is just a number which does not include any variable. So what does variable mean? Variable is nothing but terms like this: x, y, z, for that matter a, m, p. Basically an alphabet which can rather take different values. So this will be called as variable. So in a polynomial expression, that would contain several constants and variables, as you can see. This particular polynomial here, my dear friends, has the variable x. So this is basically what a variable is, and this is basically what a constant is. Now, before going further, I have been talking about expressions, right? This is a expression. Let me first tell you what the difference between the word expression and equation is, right? So these are two simple things. This is an expression, as we just discussed. It's nothing but a set of few terms. As you can see, there are 3 terms in this particular polynomial expression, right? Term number 1, term number 2, and term number 3. So there are 3 terms, and together this is called as a polynomial expression. Now, if I equate this particular polynomial expression, when I mean equating, it means putting an equal to sign. Now, if I put another polynomial expression or any other constant, to be very basic, if I just put a 0 over here, then this, my dear friends, becomes a polynomial equation. That's the simple difference between what an expression is and what an equation is. So try and understand. The difference between an expression and equation is fairly simple. Expression is a set of terms in one or more variable with different powers of that variable, as you can see. Once that expression is equated to a constant or another expression, then that in its entirety becomes a polynomial equation. So this is the basic fundamental of what a polynomial expression and a polynomial equation is. Now let's take another example to put some more light about different things of a polynomial expression. Let's take an example. 4x square minus 3xy plus 5y. Now let's stick to an expression. Once we know that what an equation is, after understanding that, let's take equations later in the chapter. Right now, let's stick to what expressions are and try and understand in detail what exactly is in store. So now, firstly, try and understand this is a polynomial expression, and as we can see, there are two variables in it. One of them is x, another of them is y. Now, in a particular polynomial expression, there are things called as terms. That is what we were exactly discussing. In this particular polynomial expression, forget about the zero out here, there are three terms. Similarly, even in this particular polynomial expression, there are three terms. So, point here being, term is one entity of the polynomial expression which is classified with a plus or minus sign in between. So basically this is one term, this is another, and this is another. You can actually take this minus sign inside and make this plus. Now this is term number 1, this is term number 2, and this is term number 3. Now on this note, let's understand that in one particular term, what are the key ingredients? Now, if I try to focus on this first term, which is 4x square, I can factorize this into three ingredients. One is 4, another is x, and the third is x again. So if you notice, if I multiply these three variables and constants, because this is a constant and these two are variables and the variable is x over here, if I multiply these three together, I get the term 4x square. So basically what we are trying to do here is trying to break one particular term. So likewise, if we go to the second term of this particular expression and if I try and break this, I'll get minus 3x and y. And likewise, if I do the same thing for the third one, I get 5 and y. So this is what terms are, and this is how we can factorize every individual term. So now here, there is one more very important thing which I want to discuss with you, and that is called as coefficient. So in a particular polynomial expression, every particular term will have a coefficient. And let us understand what a coefficient is. A coefficient is nothing but that constant term which you can see before the variables. So in this case, in this very first term, the coefficient is 4. Here, in this case, the coefficient is minus 3. And here, the coefficient is 5. So to conclude, this polynomial expression has three terms. It has two variables, namely x and y, and the first term has a coefficient of 4 with two variables x each. The second term has a coefficient minus 3 with two variables x and y which are different, and the third term has a coefficient of 5 with a variable y. So this concludes the basic definitions involving a polynomial expression. Now we will learn about different ways of classifying a polynomial expression. So now friends, let's talk about classification of polynomials. So basically, these polynomial expressions that we are seeing are classified on the basis of three different parameters. Let's try and understand what these three different parameters are and which of this parameter is going to be of utmost use to us. So classifying polynomials, as I said, is going to be on three different ways. The very first one is going to be on the basis of distinct variables. So rather, the classification is on the basis of number of distinct variables. So as you can very easily understand, the more the number of variables, the different name it is going to take. So we know that in a particular expression what a variable is. So x, y, z, a, b, all these are different kinds of variables. So if you see a polynomial expression of this kind, x plus 3, or for that matter even x square plus 3, or for that matter even 7x square plus 3, or something of those kinds, it's very easy to understand that there is only one variable in this particular polynomial expression. So this is called as a univariate polynomial. As the name suggests, this says that this polynomial expression has one variable, and that is how this particular name univariate has been coined. So on this note, if I extend this to, let's say, x plus y, I'm trying to keep them as simple as possible, although as I said, we can even write this as 7x square plus 3yx, right? Even then, the variables, number of variables in that particular polynomial expression would be 2, because there is a x and there is another y which is distinct from x, which is y. So basically there are two different variables in this particular polynomial expression. Now as I said, you can complicate this as well, like 7x square plus y cube or something on those lines. Still this particular polynomial expression would be a bivariate polynomial expression. So again, as the name suggests, bivariate means two variables. So on this line we are going to have trivariate as well, and that naturally is going to have three variables. So let's try and put a simple version of it. Let's say x plus y minus z plus 9. So now as you can see, I have three variables, namely x, y and z, and that is why the name trivariate, which means three variables. And this classification can go on further depending on how many number of variables are included in that particular polynomial expression. So the first kind of classification, as we can understand, is dependent on the number of distinct variables that a polynomial expression has. So as you can see, one variable, two variables and three variables, and likewise the names univariate, bivariate and trivariate. Now let's turn our attention to the second kind of classification of polynomial expression. This particular classification is based on the number of terms of that expression. So let me write that down here, number of terms. So the first classification was on the basis of different variables that an expression has. This classification is based on the number of terms that one particular polynomial expression has. So as we can say that, let's say if we have 3x, right? This is one term. So this becomes a monomial. So basically the number of terms, if it is 1, then we can say that that polynomial is a monomial because it has one term. Now if I try and complicate this and write x square plus 3, then this becomes a binomial because I have two terms in it, right? So the number of terms very clearly define the name of the polynomial based on the number of terms. So one term monomial, x square plus 3, two terms binomial, and lastly let's say if I put x square plus x minus 7. Now this becomes a trinomial because it has three terms. So a very simple classification directly based on the number of terms one particular polynomial expression has. So as you can see, we can try to use this classification in these examples as well. Here this is a binomial because it has two terms. This is again a binomial because it has two terms, and this becomes a fourth degree polynomial in this case because it has four terms. So this classification is based on the number of terms, and this classification is based on the number of distinct variables the polynomial expression has. Now, if you want to classify these three examples on the basis of number of distinct variables, you can very easily say that all the three are univariates. Why? Because all the three here have only one variable, which is x. So till now we understood two different classifications. First of them being which is based on the number of distinct variables, and second of them which is based on the different number of terms a polynomial expression has. Now, as I said, the third kind of classification is the most important kind of classification, which is based on the degree of the polynomial. Now, this is the classification which is going to be used extensively in this chapter and likewise further in the entire algebra of mathematics. So let's understand firstly what a degree is. So now, degree by definition is the highest index or the highest power that the variable has. So, a particular polynomial expression, let's say if I just put p of x, now this, when you put an equality sign, it suddenly becomes an equation clearly. So let's just define p of x as this: an x raised to n plus an minus 1 x raised to n minus 1 plus an minus 2 x raised to n minus 2 plus so on till a1 x raised to 1 plus a0 x raised to 0. Don't get panicky here. It's pretty simple. Let me explain through this. What does this exactly mean? Before this, we have understood what a coefficient is, right? So basically, an minus 1. So basically, this is a subscript n minus 1, a subscript n minus 2. These are basically coefficients of their corresponding terms. So these are just constants, as you can understand. an minus 1, an minus 2, a1, a0, all these are just constant terms which are hanging with these variables, and these variables are exposed to different powers. Now, as the definition of degree goes, in this particular polynomial equation, in this case, where this is an expression without the equality sign, the degree is the highest index. So I can say that the degree here is n, and n has to be a natural number, right? This n cannot be a fraction. This n cannot be a negative number as well. This has to be a natural number that even cannot be 0, because then it would just be p of x equal to constant. Because if I just say that n is 0, all these other terms are going to vanish, and then it is going to be just a0 x raised to 0. So a0 is a constant term and x raised to 0 is 1. So that becomes just a0, which is a constant polynomial. Now, if n is a natural number, let's say n is 1. Let's take the basic, simplest of all. If n is 1, then since, as the definition goes, degree is the highest power that a variable has, that restricts this equation to only these two terms. Because if degree is 1, then there is no x square term, there is no x cube term. So there is no, all these terms are gone. There is only a1 x raised to 1 plus a0 x raised to 0. Then that particular term becomes a linear equation. So let us just define this. If degree is 1, then that polynomial is called a linear polynomial, right? Because then there will be only two terms of this kind, a1x plus a0, right? Secondly, let's say if the degree is 2, right? If the degree is 2, then there will be another term over here which will be a subscript to x square. Then that is called a quadratic expression or an quadratic equation. So that will look something like this: a2 x square plus a1x plus a0. So this is how a quadratic expression is going to look like. Likewise, if you go to degree 3, then it is going to be a cubic equation or an expression depending on the equality sign if you put it or no. Then this is going to be a3x cube plus a2 x square plus a1x plus a0. So try and understand this. This classification of polynomials wholly is based on one thing, which is called the degree of a particular expression. And degree is nothing but the highest index or the highest power of the variable taken. Now, as you can see, a cubic expression has the highest index as 3, because all these subsequent terms, here x has a degree of 2, here x has a degree of 1, and here x has a degree of 0, because x raised to 0 is 1, and that is why you cannot see that x raised to 0. So here the highest power is 3, and hence the degree of this expression is 3. Now why I am saying this as an expression? Because there is no equality sign, it's an equation. So the degree here is 3, and hence it is called a cubic equation. In this case, a cubic expression. Now if you likewise go further, this can just simply go on. After cubic, it would be a biquadratic expression slash equation. And these kind of terms go on, but I guess these are the words which you should be knowing till now. So again, the gist of all this is there are 3 kinds of classification of polynomial expressions. First 2 of them are not very extensively used. They are classified on the basis of number of distinct variables. So basically, if there is only x, then it is a univariate. If there is x and y, then it is bivariate. If there is x, y, z, then it is trivariate. And you can definitely play around with the different alphabets meaning different variables. The second is the number of terms. Very simply put, 1 term monomial, 2 terms binomial, 3 terms trinomial, and so on. And lastly, the most important classification, which is based on the degree, which is nothing but the highest index or the power of the variable. Most likely we use x, and this is the general polynomial equation. This is how we present it, and the degree is n because that's the highest power of x, which is always a natural number. It cannot be a fraction. It cannot be a negative integer as well. What I'm trying to say here is, if I say that I have an equation of this kind, 6x raised to minus 2 plus 4x cube, I can't call this a polynomial expression because there is one term which has a power of minus 2, and that is not allowed. Everything has to be in natural numbers only. Okay, so and these are the words that you should know. If the degree is 1, then it becomes a linear polynomial. If the degree is 2, it becomes a quadratic. If it is 3, then it is a cubic, and if it is a 4, it is biquadratic.